All right. Good afternoon and welcome to Master Talker online class. So let's continue from where we stopped in this particular series of solving physics year one workbook solution. All right. So we have the question number 91 is where we stopped. They said that a tall boat traveling from Asaba. Asaba is a state in Nigeria. Asaba to Onitsha. Onitsha is another state in Nigeria. It's found inside Anambra State in Nigeria. So Asaba is found inside the Delta State. So Asaba is in Delta State, Onitsha is in Anambra State. So across the river, across the river Niger, across the river Niger a resultant with a resultant velocity of 50 kilometer per hour, and the river flows at 15 kilometer per hour, 15 kilometer per hour. Then I said the direction of motion, the direction of motion, what am I saying? The direction of motion of the boat, relative to the direction of water flow is okay. Solution. Now I have the water like this. Let me say that this is the water that is flowing like this. Okay, this is the water that is flowing, and somebody wish to cross this from here to here. This is the way this man wishes to cross. But the resultant force, as he's trying to cross this way, okay, the water is flowing like this. As the water is flowing like this, so he he has to be pushing in opposite direction of that water. So he has to be pushing like this. So the resultant force goes this way. So we have that, and this is the angle they will make. This is the angle they will make. So my resultant force is what? 50 kilometer per hour. 50 kilometer per hour. Okay. But if he's not strong, then the water will just carry him and go like this. In fact, if he goes like this, it will be difficult for him to get there because the water will be carrying him. He may get there, but I'm not really sure. The water might just carry him like. But if he goes in opposite direction to that water, so it will help us to get to that point. So I have that this is my theta and my resultant, and then the water flows. The water is flowing like this. So the water flows as the 15 kilometer per hour. Okay, so to get the direction now, so you have that this is opposite over hypotenuse. So I have that sine theta okay, no, this is where the man wants to get to. This is his result. As he's moving like this, his resultant is to this side. So this is his own movement. So but this is the resultant. So they're not asking us the angle. This is the resultant because it's going to result to getting to this point. Okay, this is the resultant. That is the resultant here is 50 kilometer per hour. But he's moving like this. But it's going to result to coming to that end. So I'm going to have that this is opposite over adjacent. So I'm going to have that tan theta. Tan theta is equal to opposite 15 divided by adjacent 50. So theta will now be the tan inverse of 15 over 50. So do that and get your final result. So, but you can do your own research. And then tell us at the comment section. But this is what I think personally. Okay. So we move to question number 92. Question number 92 said the velocity of a particle The velocity of a particle in meter per second varies with the time according to the equation v is equal to 3t squared minus 4t plus 4. Then I say what is the maximum velocity attained by the particle. Okay, solution. Now you should know one thing, that at maximum velocity acceleration is 0. So we need to get the acceleration. So acceleration is what? Dv over dt, which is what? Differentiate this time this. So I have what? 6t minus 4. Okay, which is equal to 0. To get that, 6t is equal to 4. So my t will now be 4 over 6, which is 2 over 3. So we now tell them that at maximum velocity, acceleration is 0. So that's what we do. That's why we did this thing. So the maximum velocity v will now be what? Now substitute. My v is equal to 3t squared minus 4t plus 4. So we have gotten t. So we have that 3 into 2 over 3 all squared minus 4 into 2 over 3 then plus 4. So I'm having that 4 over 3 minus 8 over 3 plus 4 over 1. So I'm left with 3 here. 4 minus 8 plus 12. So which is what? I think 16 over 3. 16 over 3 in meter per second. So that is the maximum velocity. So we move to question number 93. So question number 93 said a solid weighs 100 Newton when suspended in air, and 60 Newton when suspended in water. Then I say calculate the volume of the liquid. Okay, so this is very, very simple. Solution: we have that the weight in air is equal to 100 Newton. Then the weight in water is equal to 60 Newton. Okay, then upthrust in that water is equal to what? The weight in air minus the weight in water, which is what? 100 minus 60, which is 40 Newton. Okay, so then the mass will now be what? 40 divided by 10, which is equal to what? 4 kg. So I know that what? Density is equal to mass over volume. So volume is equal to mass over density. So the mass is 4 divided by density of water is equal to 1 kilogram per meter cube. The 1 gram per cm cube. Jesus, 1 gram per cm cube, or 1,000 kilogram per meter cube. Jesus. So please correct the other one. 1,000 kilogram per meter cube. So put it here. You're going to have divided by 1,000. So which is I just remember this now. Sorry. So the other one is a mistake. You can correct it. 4 divided by 1,000. So to have that, it is 0.004 meter cube. Okay, so that is that. So question number 94. Question number 94. Question number 94 said that a piece of metal weigh 200 gram in air and 100 gram in water. And I say what What will it weigh in alcohol of relative density 0.8? Okay, solution. So we have that the weight in air is equal to what? 200 gram, and then weight in water is equal to 100 gram. Then we are looking for the weight in alcohol, while the relative density is equal to 0.8. So, and you know that relative density is equal to what? Upthrust in alcohol all over what? Upthrust in water. Okay, so 0.8 is equal to upthrust. Okay, let me write it again. Relative density, upthrust means weight in air minus weight in that alcohol all over weight in air minus weight in water. So 0.8 is equal to weight in air is 200 minus weight in alcohol all over 200 minus 100. So I have 0.8 is equal to 200 minus weight in alcohol all over 100. So therefore, cross multiply. This time, this will give you 80 is equal to 200 minus weight in alcohol. So weight in alcohol will now be 200 minus 80, which is equal to what? 120 gram. So that is the weight in alcohol. Okay. So that is that. So go to question number 95. Question number 95. Question number 95 said, when is a body said to be in unstable equilibrium? Okay, you can browse that and tell me the answer at the comment section. But from here, I wrote that unstable equilibrium occurs when a slight displacement of the body will cause to topple over with decrease in the center of gravity. So question number 96, do your own research and write it. Question number 96 said, an object if an object whose mass if an object whose mass is 3 kg moves 1000 gram per cm cube or 1 kilogram per meter cube. That last question I solve is wrong. Please, density of water is equal to what? 1 kilogram per meter cube, 1 kilogram per meter cube, or 1000 gram per cm cube. So please, I'm supposed to use 1 there, not 1000. I just remembered. So please correct it. I'm supposed to use 1 there and not 1000. That is, question number 93. Okay. So the answer is supposed to be, sorry, not question number 93. Yes, question number 93. So the answer is supposed to be 4 meter cube. So divide by 1 and not divide by 1000. Okay. So sometimes you make mistake. So, but thank God for the correction. So moves in a circular path of radius. Circular path of radius 0.5 meter. Records a speed of 2 meter per second. Now say what is the angular velocity of the body of the object? Okay, solution. So they gave us that the mass is equal to what? 3 kg. Okay, and then they gave us the velocity, which is the speed, as 2 meter per second, and they gave us the radius is equal to 0.5 meter. So don't forget that radius, linear velocity is equal to what? Angular velocity over r. Okay, so therefore angular velocity is equal to what? Linear velocity times r, which is what? The linear velocity is 2 times 0.5, which will give you what? I think 1 rad per sec. 1 rad per sec for question number 96. Okay. So please, okay. Is this correct? No, this is not correct. Sorry. So I know that angular velocity is equal to what? Linear velocity r. Uh-huh. Linear velocity r. So which is what? Because linear velocity is what? Linear velocity is equal to angular velocity over r. Yes. So I have what? That is 2 times 0.5. Why is this confusing me? Oh, what am I saying? Linear velocity is equal to what? Angular velocity r. Because angular velocity is equal to linear velocity over r. Yes, this is the right thing to write, please. This one is the correct thing. So, which is what? This is 2 over 0.5, which is equal to what? 4 meter, 4 rad per sec. 4 rad per sec. Yeah, this one is very correct, please. Question number 97. This is very, very correct. So, question number 97 said a string, a string of length, a string of length 15 cm is extended by 0.02 meter when a load of 10 kg is suspended at the end. And I say, how far will it extend if a force of 26 Newton is applied? Solution. So they gave us the original length of this, that is 15 cm, which is 0.15 meters. So they gave us the first extension, which is 0.02 meters, and the first force to be 10 times 10, which is what? 100 Newton, because 10 kg is the mass. So the force converting it is multiplying by 10, which is our G. Okay, is the first one. So the second extension is unknown, while the second force is 26 Newton. But I know that my F1 over E1 is equal to F2 over E2. So my F1 is 100 divided by E1, 0.02, is equal to F2, 26 divided by what? E2. So therefore my E2 will then be what? 26 times 0.02 divided by 100. So what do you have? 26 times 0.02 then divided by 100. So I have 0.0052 meter per second, right? Sorry, in meters. So that is the extension there. So we move to question number 98. Question number 98. Question number 98 said, what is the coefficient? What is the coefficient of friction between a load of mass 1.9 kg and a horizontal surface? Then I say if the limiting frictional force is 5 Newton. Solution. So we should know that the normal reaction is equal to what? Mg, which is what? 1.9 times 10, which is equal to what? 19 Newton. So we know that mu is equal to what? Frictional force over the normal reaction. So my frictional force is equal to 5 Newton. So I have 5 divided by 19. So do that to get your answer. 5 divided by 19, which is 0.263. 2632. So how will you know that you are correct? This must be less than 1. So don't forget that. 99 said, given that f is equal to what? I plus 2j plus 3k, comma, they now say find the work done by the force. Find the work done by the force about a position r, which is equal to I minus 2j plus 2k. Okay, so work done is equal to what? F cross r, which is equal to what? So I have my plus I minus j plus k. So I have my 1, 2, 3, 1 minus 2, 2. So if I take plus I, open bracket, cover here, left, right, 2 times 2, 4. This time this is 6, so I have plus 6 because it's minus then minus 6. So to have plus 6, all right? Permit me to write it down here. I don't want to go far. So let me say that this is equal to, I'm taking plus I. If I take plus I cover here, I'm going to have left, right. This time this is 4 minus, this time this is minus 6. So minus minus will make it plus 6. Okay, then I'm taking minus j, covering here, this time this 2 minus this time this is 3. So I'm taking plus k, I'll cover here, this time this is minus 2, this and this is another minus 2. So I am left with 10I minus j, with minus here will make it plus j, so minus 4k. Okay, so that is that for that. So the last question for this particular video, which is question number 100. So question number 100 said, given that a vector A is equal to 6I minus 4j plus k, then I say then the divergence of the curl of A will be solution. Now when you have divergence of a curl of any vector at all is 0, so no need to solve anything. So div curl A is 0. So thank you very much for watching. Please like, share, subscribe, and comment. Bye bye.